And before we jump into backend development, let's see all other options. What software developer you could be. So the software developers. And first thing that we need as software developer is a piece of hardware where our software will be running for, which is basically any device that you see around you, from the laptops to mobile phones and tablets, any device that you have at home, from microwaves and refrigerators to some small sensors that you can build smart home with. Also, it could be robots, self-driving cars, or even rockets. And for every hardware, there is a small piece that brings this hardware to life, which calls firmware. And for the most of devices, you will also need an operating system who take care that all devices' functions will work properly. Yeah, for small devices, you can skip operation system part and program them directly, but for the most other parts, your applications will be on top of operating system. And you can focus directly on end users. So for the software, you can set boundaries roughly here. And let's see types of developers. Well, first of all, you can be an embedded engineer with deep knowledge of architecture, and your main focus will be to bring the hardware to life. Then you could be a system engineer and build operating systems or some systems for the business. From the applications, you could build desktop applications, which in worst case scenario means that if you have an application, then for every operating system, Linux, MacOS, or Windows, you will need to build a specific version of your applications. In good case scenario, you have something that cross-platform. And the same applies for mobile developer. For every operating system, iOS or Android, you will build a separate application. In the best case scenario, you have some tool that allows you to write code only once. And now let's talk about one special application that calls browser and the web developers who take care of this. And you will think, oh, this is convenient. Instead of rewriting our application for the every operation system, we could just have only one code base and use the browser. But it would be too simple. Chrome, Firefox, Safari, a lot of others. And not many years ago, it was a real pain because every of them required a specific piece of code so the interface could look the same for the users. But nowadays, it's much better. So web development has three main parts. You would be a front-end developer, and with the main focus of user interface. So no matter what browser or which mobile platform, the user should have the same amazing experience with our application. The second part is the backend part, with the main focus on the core functions that independent of browser or mobile platforms. And backend usually contains the actual code that does all calculations and modifications and database. And the one way of communication is application programming interface. And end users can interact with user interface, and user interface will call application programming interface, which gets some data if it needed from the database, does some manipulation, and return the result back to user interface so the users can see it. And the code could be triggered not just by users, but like with internal event They could also can trigger some calculations and maybe push the results to the users. And the third part we need is infrastructure, because backend code runs usually in some different place, somewhere in the cloud, which is usually means that there is proper server as a hardware and a bunch of people who takes care that its server up and running 24 hours per day, so we don't need to take care of it. So we can focus only on our data there and how do we run our applications. And if the project is not huge, then you can manage it all by yourself and be a full stack developer. And otherwise, you will have dedicated teams for all these parts. And besides this classic scheme, there are a lot of other directions that you could go. You could be a game developer. You could build applications for augmented reality or virtual reality. You could go in artificial intelligence field and use machine learning algorithms for picture recognition, voice recognition, whatever recognition or recommendations. And you could be focused more on the data and be data scientists. You could be focused more on building systems with blockchain, or you can go deep into security and so on. And here on the boundary, we have quality system engineers, which on one hand could write code for automation tests for all the systems, or on the other hand could just do manual testing. And here we could put designers of user experience and user interfaces, so they do research on the users and provide convenient and beautiful solution for them. Then the front end implements for every browser or platform. And here you could be a business intelligence guy who analyze the whole bunch of data that they have and make some predictions for the future. And also we have a lot of managers, from the product owners who takes care of the product to project managers who takes care of the teamwork is expected. And we have someone from the C-level who provides strategy and vision. And one specific option here is when you provide applications to the users, but without writing code, but using builders. For example, like WordPress, Shopify, Squarespace, so constructors with specific purpose, or using constructors like Coda when you can build anything you want without worrying of all this stuff. And this course will be focusing on the backend development, but we will talk a bit about front-end part to understand how should we write our APIs. So front-end guys will be happy. And we will talk a bit about infrastructure part and how should we write our applications so it could be easily measurable and scalable in the clouds. And the main point is just there are a lot of options. And if you start your career as developer and you're not really satisfied with your path, then you could try a lot of other fields and find the area where you will be extremely happy. For example, many years ago, I was a full stack developer, but every time I wrote specific code for the browsers that does the same, it made me really sad because it felt like wasting of the time. And I also should support like Internet Explorer 6. And so I quit the job really fast and I switched to backend development when you always focusing on building something new. And since then, I'm extremely happy with development. And since we're here, it's a perfect time to talk about programming languages. Let's put some scale, and it will be efficiency. Efficiency for the developers to use this programming language, and efficient, like fast for machines to execute. And first of all, hardware understand only one thing is machine code. So all these zeros and ones. And that's why we need programming languages, because it's not efficient for the human to enter this code. And so the first is assembly languages. This is writable for the humans, but you should keep a lot of things in mind. Besides the purpose of your program, you should take care of a lot of stuff. So it's fast, but not very comfortable for writing. And then we have C or C++, which is a higher level, which is higher level than assembly, and it's more pleasant to human to write. But you still need to keep in mind a lot of things about memory pointers besides the actual purpose of your program that you're running. But it's still the very common choices because it provides a great performance, and it's like main language for if you want to be embedded or system engineers, and in general for any other field. If you need like really great performance, then you may use C or C++. But there are more convenient options for writing the code. For example, we will be using the Golang because it's a great combination. It's not only fast enough for computers, it's also a big pleasure to work with. The thing that I like the most is that the Golang is result-oriented language. Seriously, you can be focused exactly on the purpose of your application, and Golang will take care about everything else. So garbage collector will take care of memory, and you have the minimum amount of keywords, so you never waste your time choosing which cycle do you need. You have only one for, and you don't waste your time arguing about code style. There is only one code style. And when you need to write code in a concurrent way, you have minimum amount of primitives that allows you to write really clean and understandable code. Plus, Goroutine was designed keeping hardware in mind, and that's why they're really efficient way of using computer resources. But for other areas, you can find that another language or framework will be most efficient way to write your application. And for example, for machine learning, you most likely choose Python because it contains a lot of libraries specific for that. And so first choose the area what you want to develop, and then research what tools will be the best specifically for your project. This was the last part of introduction, I promise. From the next video, we jump into coding.